Hypothesis testing. A hypothesis is a proposed answer to the research question based on limited evidence. Hence, data has to be collected in order to test its veracity or truthfulness. There are two main approaches, the critical value or classical approach and the p-value approach. In the critical value approach, you are to compare a test statistic with a critical value on a curve. And the p-value approach, you are to compare a p-value to a significance level. Okay, basically. Now, for the p-value approach, using Excel, SPSS, Minitab, or Jasp, Varsar Stats, or any other statistical software, we are going to outline the steps for the p-value approach using a software. First, you have to state a pair of hypotheses. One is called the null, symbol HO, and the other, the alternative, HA or H1. Step 2, you have to input your data into the software, be it Excel or Jasp or whatever you are using. Then you have to process the data in that software, and that software will give you an output. Okay. Now, from that output, you're going to identify the p-value. And then you're going to compare this p-value to your significance level. So if you use 0.05, you're going to compare the p-value to your alpha, which is 0.05, if that's what you use. Now, you have a decision to make. You're going to reject the null, that is HO, if the p-value is less than 0.05, less than your significance level. But you do not reject the null if the p-value is greater than the significance level. If the p-value is not less than the significant level, you do not reject the null. There are two types of errors that can be made. Type 1 error occurs if the null hypothesis is rejected when it is true, and type 2 error occurs if the null hypothesis is not rejected and it is false. Now, your final step is to conclude. If the null is rejected, then the alternative is the conclusion. But if the null is not rejected, then the null itself is the conclusion. Always remember that you will start the test with two statements, the null and the alternative. The null and the alternative is symbolized HO and HA or H1. After the test is done, only one will be the conclusion, either HO or HA or H1. So either the null or the alternative will be the conclusion. Now here's a diagram with a list of hypothesis tests that are commonly used. And you have the parametric and the non-parametric tests, the one sample and the two samples. In this presentation, we are going to make an example with two samples chi-square tests. Two samples, independent samples, chi-square. So to begin a chi-square test of independence or no association, here it is, chi-square. We have to, these are the null and the alternative that you have to use, because this test deals with the verification of association or not between two variables, if they are linked or not, if there is any dependency or not between them. So the HO will be saying that there is no association between the two variables, that they are independent of each other, while the H1 will be saying that there is an association between the two variables, they are dependent on each other. So this is how you begin a chi-square test for independence with these two hypotheses. So here's the setup, here's the example that we are going to use. Example 1, chi-square test for independence. A researcher wanted to determine if score was independent of residential area. If residential area affecting score, so the residential area will look like the independent variable and the score is the dependent variable. Okay, so we want to know if there's an association or not between them. The values she collected are presented in the following table. Help her to reach an informed conclusion using a significance level of alpha is equal to 0.05. So we're going to use our significant level of 0.05. So first we have to state the null and the alternative hypothesis. So here we can copy this null and the alternative and modify it, H1, H1, or H0 and H1. So that's the first step. Okay, now the variables in play here are residential area. It comes first because it appears to be the explanatory variable. Let's call it variable A. And the other variable there is score. the response variable. So is there a significant relationship between the two? Okay, so we can use the chi-square test for independence for that. So the null is saying that there is no association, that they are independent of each other, and the alternative is saying that there is an association, they are dependent on each other. So let us perform the test using these values, using this data to see whether or not. So we're going to input this data into Excel. Okay, so one column, we're going to call it residential area. And the other column, we're going to call it score. Now the residential area can be central, suburb, or rural. So there are 60 central. So since we started with 1 already, so we'll end at 61 for central. Right. And suburb, you have 45 suburb. So 45 and 61, that will bring us to 106. So we're going to stop at 106 for suburb. Okay, and rural now is 50, so we're going to stop at 156. And actually the total, as you can see, the total is 155. So remember, we started, the first row had the labels already, which is residential area. So we go one more. So instead of 155, we stop at 156. Right. Now for score now, let's just centralize this. Right, for score, you have less than and more than 50%. So for less than 50%, you have 15 central. Okay, so since we started here, we start one more, so you're going to stop at 16. Okay, and for more than 50% for central, 45 of them. 45 and 15, that will give us 60. But remember, we're stopping at 61. So for more than 50 for central, we'll stop at 61. Okay. Now, for less than 50 for suburb, there are 25 of them. Okay. Now, remember, we started at 61, 25, so we'll end up at 86. Okay. That's for less than 50% for suburb, and 20 for more than 50% for suburb. Okay, more than 50%, 20 for suburb. Okay, so we're going to stop at 86 and 20, 106 for suburb. Here it is. Now, for rural, we have 40 less than 50%. Okay, 40 less than 50%. So that will bring us to 146. That's for less than 50% for rural, and for more than 50% is only 10 of them. And that will bring us to 156. Okay. Now, we have our data in Excel. However, if you go to data and data analysis, if you don't have data analysis, you can look at a YouTube video to input data analysis, add data analysis to your Excel. You will see that data analysis does not have chi-square test for independence. So it is impossible to do a direct chi-square test for independence using Excel. So what we're going to do, we're going to use Jasp. Now, in order to use Jasp, now we have to save this file, this Excel file. Let's save it in math recordings. we have to save it as CSV UTF. So you just toggle down here and you look for CSV UTF /8, save, and you say yes. Yes again. And this is done in order for Jasp now to recognize that Excel spreadsheet, because when you go to Jasp, you go to show main menu, those three blue horizontal line, you click on it, you go to open, and you go to computer, and you go to browse. And since you have saved this as CSV, Jasp will recognize it, okay? This Excel spreadsheet that you have saved, you click on it, you can double click or click open, and here it is imported into Jasp. Then you go to frequencies, and you go to the first contingency tables. You have the classical and you have the Bayesian. You go to the classical, first one, click on contingency table, and here the rows and columns. So it shows you, and as you can see, the blank chi-square test is waiting, and the contingency table is waiting for it to put the data. So residential area, let's put it in rows, and scores, let's put it in columns, and automatically you have an Excel, a Jasp output with the contingency table and the chi-square test output. You just click toggle down here and you copy, and then you paste it now in your Word document. Here it is. And then you identify the p-value. The p-value is 0.01. All right, as you can see right here. And 0.01 is less than the significance level of 0.05. And we said that when the p-value is less than the significance level, you reject the null. You can remember, right? In our decision, if the p-value is less than the significance level, you reject HO, you reject the null. And if you reject the null, then the alternative is the conclusion. Okay, and this is what is actually happening. So you can say that since the p-value of 0.001, sorry, is less than the significance level, and here we have our significance level of 0.05. Alpha is equal to 0.05. Remember, that's a p-value approach. We reject HO. HO is a null. All right. And consequently, or therefore, we conclude that there is an association between residential area and score. They are dependent on each other. Put a comma here. And here is an example of a chi-square test for independence using both Excel and Jasp.